So this is the second page of lesson 13. Now we're going to take what we just learned and combine it with possibly GCFs or difference of perfect squares. So on this first problem, when I look at it, I see a trinomial. I do notice there's a number other than 1 in the front, and we haven't really dealt with how to factor those, but we know the very first thing we look for when we're factoring is a GCF, and on this one we do have one. So here I'm able to factor out a 2. And I'm left with a trinomial in parentheses. So at this point, I can check and see if the method we just used, trinomials a equals 1, will work. And I do see that I have factor pair that will work to add and multiply as I would like. So I need to multiply to negative 15, add up to negative 2, so negative 5 and positive 3 will work. Moving on to the next one, and honestly, this is a page where at any point you could just go ahead and try it and then come back and check, because in class we will be practicing this page and letting the students try all of them before I do them. So in the next one, I see another situation where I have a number in front of the z squared. I definitely want to factor out a negative number. We said we never want the lead term being negative before we go into our next factoring step. So I do need to change signs here. 72 divided by 3, a little motion here, so it's a 24. So I keep my GCF in the front, put my z's down, and then the numbers that will work are negative 6 and positive 4 for the pattern median. Moving on to the next one, I'm always checking for GCF first. I can tell it's not going to be a trinomial problem, basically because I only have a binomial. So I look, I do have a GCF of c cubed, so I'm going to take that out and put it in the front, leaving me with 36 c squared minus 25. I'm just changing the colors of the GCF, so we got that. That's still part of the problem, but I'm focusing on just the remaining parts of factor. So looking at this, I have 2 terms I've already taken out of GCF, so something that I am going to want to check is difference of perfect squares, which I do have here. So that's going to be 6c in the front, and then plus 5 minus 5, and then that one is fully factored. Moving on to the next one, we have a GCF. This time I want to make sure I got out the 5 and the x, leaving me with x squared minus 5x plus 6. The 6's can be tricky because 2's and 3's and 6's and 1's can come kind of close to doing the same thing. Like I might initially think that this is a 6 and a 1, but that won't work to add up to negative 5. I do have to use a negative 2 and a negative 3 on this one. At this point, if you are just copying, you should definitely just try the last few to make sure you're getting it, and then come back and check. So I'm going to go a little faster through these. GCF here is 4x squared, leaving me with x squared plus x minus 6. So I have my 4x squared in the front, and then this is going to factor to x plus 3, x minus 2. The next one has a whole lot going on. We need to look a little more carefully for a GCF. I'm taking out a negative to keep that lead term positive. Looking at my x's, x cubed. Looking at my y's, just a y. So then what I have left here is going to be 4x cubed y minus 6 x squared y cubed. And then I have a minus 1. Remember that last term doesn't cancel out. This is a trinomial that I have left, but it is not in any sort of structure where I could do the method that we learned in this lesson, so that is the end of that problem. The next one, maybe I do, maybe I don't have to play around with this 18 and 128, but the GCF of those two is a 2. I'm taking out an x and a y. That leaves me with 9x squared minus 64. And then I do have, for this one, the difference of perfect squares, where we have subtraction there. So I have a plus 8 minus C. The next one, there is no GCF, right? So we've had GCFs on the rest of this page. So I'm going to go directly into that trinomial method. In class, I will show you kind of like a calculator trick if you're having trouble finding factor pairs. The one for this one is negative 16 and positive 4 will work for what we need. The last two problems, so this one I'm taking out of 4. And numbers that will work to add and multiply are negative 10 and positive 3. And the last problem, I'm going to take out a negative 6x. And we have difference of perfect squares. So this page is a good mix of what we've done already. If you were able to kind of get through it and determine what the structure and what you should do on each one, that's a good spot to be in.